In this video, we have some identities to establish or verify. You can pause the video and try the first one, and then I'll come back. Okay, so let's look at the first one then. Cosine to the fourth theta minus sine to the fourth theta is equal to cosine of 2 theta. Trigonometry is a lot of algebra. You have a good foundation in college algebra, you should do okay in trigonometry. You look at this, and we're going to start with the left side. When you establish an identity, normally you want to start with the most complicated side. Something like factoring x to the fourth minus y to the fourth. You should look at that as the difference of squares. Because x to the fourth and y to the fourth are square terms, because you can write x to the fourth as x squared and then quantity squared. You can look at that as this. This would be the same thing. As this. So we have a formula from algebra that says if you have the difference of two squares, it's the difference in the sum of the square roots. So I can write this then as x squared minus y squared and x squared plus y squared. And then I could continue factoring this one if I wanted to. This one, that's as far as I would go. So we apply that to this particular problem here. Difference of squares. So this can be factored then. I'm starting with the left side. So I would write the left side over here. Okay, so this would go over here. I'm not going to take the time to do it here, but you always want to write it out. So cosine to the fourth theta minus sine to the fourth theta. That's the difference of squares. So we just write this cosine squared theta minus sine squared theta. That would be one factor. And then the other factor would be cosine squared theta plus sine squared theta. So those are two factors of the left side. And of course, one of your fundamental identities tells you that if you have the cosine squared of an angle plus sine squared of the same angle, that this is always 1. And then you have another identity that tells you that if you have cosine squared of an angle minus sine squared of the same angle, that's always going to be the cosine of double that angle. So I get cosine 2 theta times 1. Of course, gives you the cosine of 2 theta. And sometimes you'll put this in parentheses just to make sure that you know it's the cosine of the whole thing and not the cosine of 2 times theta. But either way, this is the result, cosine at 2 theta. Now this one you have sine of 3 theta over sine theta minus cosine of 3 theta over cosine theta. And we want to show that that's equal to 2. So again, take a pause and see if you can work it, and I'll be back. Obviously, the more complex side is the left side again. So I'm going to start with that side. Sine of 3 theta over sine of theta. And I'm going to leave the parentheses off just to make it easy to write here. And this is minus cosine of 3 theta. Okay, so put out the left side. And then you say, well, what are we going to do with this? I got sine theta, cosine theta. And of course, if you've done enough identities, you know that normally when you have a sum or difference of terms, best thing to do is combine and write it into one expression, and then take another look at it and see what you can do. So I can see that got a fractional expression here and over here involving trig functions. The common denominator is sine theta, cosine theta. And probably the easiest way to do this is just to cross multiply here. Basically what I'm doing is multiplying this one by cosine, so I can get the same denominator, and multiplying this one, the numerator and denominator, by sine. So this is going to come out to sine of 3 theta cosine of theta minus cosine of 3 theta sine theta. And then you look at this and say, well, what are we going to do with this? But this should look familiar. You have sine, cosine, then cosine, sine, the 3 theta and the theta. That should remind you of the sum difference of angles involving sine or cosine. In this case, sine. So we're talking about this formula right here. Anytime you have the sine of the difference of two angles, that's equal to the sine of the first angle, the cosine of the second, minus the cosine of the first, sine of the second. So what that simply means then, the numerator of this one then can be written as the sine of 3 theta minus theta. If you look at this, according to the formula, it's the sine of the first angle, cosine of the first, so sine of 3 theta, cosine of theta, minus cosine of the first, sine of the second. So there you have it. And that's over sine theta, cosine of theta. So what do we have here then? Just do the subtraction there. This gives me sine of 2 theta. 3 theta minus theta. And that's going to be over sine theta cosine theta. So you wind up with sine of 2 theta over sine theta cosine theta. So I'm going to take this back up here. We have an identity that tells us that the sine of 2 theta is 2 sine theta cosine theta. So 2 sine theta cosine theta. And then of course that's over sine theta and cosine. theta. Well, you can see these are going to divide out. Sine theta, cosine theta, cosine theta, divide out to 1. So that gives me 2. And that confirms or establishes this identity. Thanks for watching. We'll see you next time.